Okay, so this is how to solve a 3x3 system using your TI-84 calculator. And so the first thing you want to do is make sure your system is set up to where all your variables are lined up. You want your first variable here, so all of these are my A's. These next terms are my B terms. And then the last column is my C terms, all lined up. And then you're going to have your equal signs lined up, and then your constants. And so once you have this set up, you can use a matrix to capture just the coefficients. And so when I set up my matrix here, it's going to have three rows and 4 columns. And so we're going to have a 3x4 matrix to capture each of the coefficients. And so for the A's, I'm going to have a 6, 7, 2 in the first column, because those are the coefficients of A. And then for the B's, be careful not to lose any negative signs. You're going to have 2, -5, 8. And then for the C's, you're going to have a -3, and then if you don't have a number in front of the variable, it's a 1. So you need that 1, and then a 3. And then for the constants, same thing, -17, 72, and -21 would be the fourth column. Okay, and so once you have your matrix, you're going to put that matrix in your calculator. And so the matrix home button is right here where it says matrix in blue. And so you're going to press second matrix, and then you're going to have options for names, math, and edit. You always have to edit first, so you kind of go in reverse order. You're going to do edit, then math, and then call on it by name. And so going over to edit using your right arrow, choose option 1 for A. We'll store it in matrix A. And they're asking for the dimensions. So this has 3 rows and 4 columns. If you accidentally switch that, you'll tell because you won't have enough rows or columns. And so you're going to type in each of these rows. And so every time you press enter, it's going to take you to the next column. So just type 1 row at a time. So 6, 2, -3. Making sure you're using the negative button and not the minus, or you'll get an error. 6, -3, and then -17. And then the second row would be 7, -5, 1, 72. And then 2, 8, 3, -21. And so I do a quick scan down the columns and make sure they say what I want it to do. So 6, 7, 2, 2, -5, 8, -3, 1, 3, -17, 72, and -21. Once you have your matrix in, you need to quit. So second, quit. You need to get out of this matrix, otherwise you're going to keep typing into the matrix, and that'll mess it up. So then you go back to the matrix home screen, second matrix, and now we can see it's stored right here. And so we're ready to go to math. And then the math option we want, if you scroll up, you'll get to it faster. We want RREF, not just REF, but RREF. And so you're going to choose option B, and then you have to put matrix A right here. So you go back to the matrix home screen and then choose option 1 so that it says RREFA. And then if you press enter, you should see zeros everywhere except the diagonal. The diagonal should always be 1s. And so how we would read this matrix, augmented matrix, that's what it's called, this system, is your X equals 4, or your A equals 4, your B equals -7, and your C equals 9. And so it's telling you the solution. And so you would be able to conclude from this screen what each variable is. And so this would be A equals 4, B equals -7, and then C equals 9. Okay, and so on the next page, we're going to practice setting up each of these matrices. And so if one of your variables is missing from the system, you need to fill in 0 for the coefficient. That's why they didn't even write the variable. If you have the variable listed but no number, that means it's a 1. Okay? And then you can put a plus there, and there's no y, so I need a 0y. It's important to have these placeholders because you can't leave blanks in your matrix. And so my x column is going to be 1, 0, 0. My y column is going to be 2, 3, 0. My z column is going to be 1, negative 1, and 3. Don't lose your negative signs. And then my constants are 9, negative 1, and 12. Over here, we're missing some terms. And so we have 1x plus 2y plus 1z equals 4 for our first equation. In the second equation, we're missing our x term. So there's a 0x plus the 4y minus 3z equals 1. And then here we're missing the x term again. So 0x plus 1y plus 5z equals 6. Okay, and so when I make my matrix, you can use parentheses or brackets for your matrix. We have 1, 0, 0 for the x's. We have 2, 4, 1 for the y's. And then we have 1, negative 3, 5. And then we have, for our constants, 4, 1, 6. Okay, and then the last one's pretty straightforward, just filling in some invisible ones. We have 2, 1, 4. We have negative 1, 1, negative 2. We have 1, negative 1, 2. And then 4, 11, 5. Okay, and so to solve each of these systems, we do the same calculator steps. Okay, and so for number 2 here, you go back to the matrix home screen, second matrix, and then edit first. We already said 3 by 4, and so we can just type over the first matrix. So 1, 2, 1, 9, 0, 3, negative 1, negative 1, 0, 0, 3, 12. Okay, and so I always do a double check along the columns, make sure all my numbers are good, I didn't lose any negatives, and then you have to quit, second quit. And then go back to the matrix home screen, choose math, scroll up to the RREF, and then second matrix, choose option A. Okay, so I see the ones on the diagonal, and so that tells me 3, 1, 4 are my x, y, and z. And so as an ordered triple, you would label the solution 3, 1, 4, putting it in alphabetical order. So x, y, and z. Okay, same thing for this next matrix. Second matrix edit. Type over the last matrix we had, 1, 2, 1, 4. 0, 4, negative 3, 1, and then 0, 1, 5, 6. Do a quick scan, 1, 0, 0, 2, 4, 1, 1, negative 3, 5, 4, 1, 6. Second quit, second matrix, math, scroll up to the RREF, second matrix A. And so I see 1s on the diagonal and then 1s for all my answers. And so the ordered triple here would be 1, 1, 1. Right? And this last one is going to be a special case. So if you've tuned me out up to this point, you might want to tune back in because something weird is going to happen on this one. So I'm going to edit, replace all these values. Do a quick check, 2, 1, 4, negative 1, 1, negative 2, 1, negative 1, 2, 4, 11, 5. Second, quit. And then second matrix, math, scroll up. Second matrix, 1. Okay, here you do not see 1s on the diagonal. That tells you this is a special case. Okay? And so this last row tells you which kind of special case. So if you see that you don't have 1s on the diagonal, look at the bottom row only. And so the bottom row of this solution was 0, 0, 0, 1. That's an equation that would say 0 equals 1. All my variables disappeared and left me with a false statement because 0 does not equal 1. And so this would be a no solution situation. Okay? And so that's what you want to watch out for is when you don't have 1s on the diagonal. And so this summary table shows you the issue. And so if you have 0, 0, in this case it was a 2 by 2 system, but if you have 0, 0, 0, 1, no solution. Whereas if I ended up with 0, 0, 0, all zeros, and for our 3 by system there would be 4 of them, that would be infinitely many because 0 does equal 0 would be true. Whereas over here, 0 equals 1 would be false. And be careful because if you end up with, I'm going to put this in a little cloud. If you end up with 0, 0, 1, 0, that's not a special case. That just tells you your z value was 0. So that's not special. It's only special if you have all zeros on the left side. Okay, and so if these were our results, we could interpret their solutions. And so for this example, we have 1s on the diagonal, 0s everywhere else. So this is our solution. They just happen to be decimals, and that's okay. You can have decimals. Most of the time, they're going to be whole numbers or nice decimals. So if you get crazy decimals, there might be something wrong. So just double check your input matrix. In this case, I have a row of all zeros. That's my 0 equals 0. So that's infinitely many solutions. And that's going to be one of our special cases.